I'm going to do is, a lot of your teachers do not tell you how to determine if a number is divisible by 7 or 8. So I'm going to show you right now and prove it. Because in math, the cool thing is you can always prove everything by some theorem and not just a theory. So using principles of logic and usually some sort of algebra, you can do a proof and you can show why something works the way it does. So that's what I'm going to do here. Now look, divisibility rule I came up with for 7, and I came up with my own for 8, which I'm going to prove as well. But I'm going to look at a number. This is divisible by 7. Why? 25 minus twice the ones digit, which is 4, gives you 21, and 7 divides 21, so therefore 7 divides 252. Now why is that? We're going to say that 7 divides some number which can be written as 10b plus a. This is the divide symbol, just like it's going into it. We're going to quantify this because otherwise it would be 7 divided by 10b and then plus a. So you want to make sure that this whole thing is a quantity. And then we're going to say this is true if and only if. Now if you haven't seen this before, it's not a typo. One of my professors wrote something wrong and called it a typo. It's like, no, that's a righto or whatever you call it. That's just a word because I said it's a word. If, IFF means if and only if. So for instance, a triangle is equilateral if and only if it has 3 equal sides and thus 3 equal angles, which are 60 degrees. So that means if and only if. Now an example of a statement that's not an if and only if statement is if an object is a square, it is a rectangle. However, the converse is not necessarily true. You can have a rectangle without being a square. But if it's a square, it's by definition automatically a rectangle. 7 divides a number, and 10b plus a, what does that mean? Well, that number I just had, 252, this is b, and your ones digit, so that's all this is. The ones digit is a, and what you do is you look for this, and you have to put this as a quantity, b minus 2a. That's exactly what I did. 25 minus 2 times a, which is 2, that's 4, that gives you 21. So that's what this means. So I'm going to do the easier part of the proof. I'm going to show you why this works. Here's another one. I know that's true, so 7 divides 364, so there is b, the other b, and there's a. So 36 is b, 4 is a, so 36 minus 2 times a, which is 4, so that gives you 8. Well, 36 minus 8 is 28, and 7 divides 28. It's 4 times 7, so because this is true, this is true. So we're going to algebraically prove this. And so when you do a proof, you have to do, this is called a bidirectional statement. It means that if this is true, then this is true. But it also means if this is true, then this is true. So the converse is always true. We're going to say that b minus 2a, 7 divides that, means that it's 7 times some integer k, and it has to be a general integer for some general integer k. So now what are we going to do? Well, we want to get this right here, this part, looking kind of like this. So what do? Well, it makes sense to multiply both sides by 10. So we're going to multiply by 10 both sides of the equation. It's going to give us 10b minus 20a, and that gives you 70k. Now, all we need to do is get this 28, this minus 20a looking like just a. So it's going to be 10b. What we're going to do is we're going to add 21a to both sides, and that gives you, you go from minus 20 to just 1a, so that's 70k. We just added 21a to both sides. And so now you have this right here, and all you have to do is factor out a 7 from this. And pretty clearly, you can see that you can indeed factor out a 7. This can be 10k plus 3a. So you've proved that this implies this. That's, in my opinion, the easier part, because the trickier part is proving the other way. So let's do that now. So just a couple of steps. We multiplied this by 10, and then we added 21a to both sides to take us from here to here to get us looking like that. So now we're going to go the other way, and that one's a little bit trickier. And by the way, that last part is an integer, that, 10k plus 3a. That part, you have to, we already know that a and b and k were all integers, so then the entire thing was an integer times 7. You do have to mention that. I forgot to mention that, but that is kind of, it seems trivial, but it's actually important, because if it were a fraction, then you couldn't actually prove that that's an integer. But because that was an integer times 7, then we proved divisibility. So now let's go back the other way. Let's say that 10b, so we want to get from here to here now, plus a is 7. We're going to use m just to not confuse it with k. 7m, but it's the same general idea in that m is generalized to be anything. It has to be some arbitrary, it doesn't matter what it is, it just has to be some arbitrary m. So we want to get it looking like that. Now how we can actually go to this, but how did I think to get, just get from here to here in one step? Well, what we did, it's going to be, how do we get from 10b to b? We subtracted 9b from both sides. And then, to get from a to minus 2a, we had to have subtracted 3a from both sides. So, wow, this thing sucks. This is the part that stumped me for a little bit, because I'm like, how in the wide world, unless you have the right linear combination of b and a, how do you prove that's divisible by 7? And that stumped me for a little bit until I realized, wait a minute, you can actually use this right here and solve for a. So a, all you have to do to solve for a is subtract 10b from both sides. So you get 7m minus 10b. So what you do is you substitute that value in for a. So now you can write this as 7m minus 9b minus 3, and then you substitute in this. So that's going to be 7m minus 10b, and that gets rid of a. And so now you distribute here. These things are terrible. I'm going to get a new set of these. Okay, so now we have 7m minus 9b minus 21m. And then remember, this is negative times negative, so it's going to be plus 30b. And so now you get, if you combine like terms, you get 7 minus 21, that's minus 14. So it's negative 14m, and then minus 9, and then plus 30 would be 21. If you think of 30 minus 9, that gives you 21. So it's plus 21b. And of course, now, your last step is you're looking to factor out a 7. Well, guess what? 14 and 21. You see those two numbers? There we go. Negative 2m plus 3b, or 3b minus 2m. Doesn't matter how you write it. And then, of course, this is an integer. So it's an integer times 7. So there you've proved divisibility by 7. Pretty cool, huh? Okay, so now the rule for 8 that I came up with is this. First of all, we know that, well, this is pretty obvious. 2 times 5 is 10. And we're going to write the exponent here. 2 squared times 5 squared. That's 4 times 25. Gives you 10 squared, which is 100. And then we have 2 cubed, which is 8. And that's a crappy looking 3, so I'm going to just pretend that one is a good thing, is you can just erase with your fingers there. 8 times 5 cubed, which is 125, gives us 10 cubed, which is 1,000. So we know that 8 then goes into 1,000. You can notice this pattern. This works for any, as long as the exponents are the same. So that would mean that 2 to the 4th, which is 16, and that's 5 to the 4th, which is 625, goes into 10 to the 4th, or that'll be 10,000. And then 2 to the 5th times 5 to the 5th, that's 3,125 times 32 is going to be 100,000, and so on. 2 to the 6 times 5 to the 6 is 10 to the 6, and which is 1,000,000, and so forth down the line. So anyway, we know that 8 goes into 1,000 by a factor of 125. So therefore, it does not matter what the value of the thousands digit and anything to the left of that is. All we have to look at is those last 3 digits, the hundreds, tens, and ones digit. So 8 divides, we're going to write this out, kind of unlike the last one. I'm going to write it like this: 100 times C, where C is the hundreds digit, plus 10B, where B is the tens digit, and then plus A. And then again, that if and only if, here it is, C plus, and then what you do is you take 10B plus A, you extract those last 2 digits, because 2-digit number divided by 4, if it's divisible by 8, it's automatically divisible by 4, and of course 2. So you know it's divisible by 4, so you know that quotient will be an integer, and you just simply add to the value of the hundreds digit. So for instance, well, that number I just had, let's see, 252, well, by this test, that's going to fail, because if you divide 52 by 4, it is divisible by 4, but not 8, because that's going to give you 2 times, that's going to give you 2 plus 13, and that's 15. And the rule here is this has to be even, and 15, of course, is odd, so this would fail the test. Now 256, actually that is 2 to the 8th power. 256 would pass, because 2 plus 56 over 4, that's 14, gives you 16. Check, that's even. So 256 is divisible by 8. By that test, let's see, let's look at another one. How about 752? That will be divisible by 8. Plus 7 plus 13, that's 52 divided by 4. So you divide by 4 to get from here to here, and that gives you 20. And 20 is, of course, even. So 752 is divisible by 8. Now, why does this work? And again, this is actually going to be a simpler proof than the one for 7, at least that second part. Again, you have to prove that this implies this, and then the converse of this implies this. So we're first going to work from here to here, and we're going to say that 100, this means that 100C, C is the hundreds digit, plus 10B plus A is 8K for some integer K. Oh, this thing's terrible. I'm just going, get rid of this piece of junk. Okay, maybe this thing is revived by now. So that's 8K for some integer K. Hopefully you can actually read it. Alright. So how are we going to figure this one out? How about this? We're going to divide both sides by 4, and that's going to give us 25C. Well, it's a tiny bit better than it was. 25C, we're dividing by 4, so we can, since the denominator's common to everything here, we can just simply write it like this. and 8k divided by 4 would be 2k, and of course that's even. So we're kind of to an even number here. And now all you have to do is write it as c plus 10b plus a over 4. That's those last two digits extracted as a number itself divided by 4, which gives you some integer, because we know it's divisible. If it's divisible by 8, it has to be divisible by 4 as a prerequisite. Sort of like you have to take algebra before you take calculus to be able to do the problems. So this is going to be 2k. Now how do we get from 25c to just c? We subtracted 24c from both sides. And of course this is also equal to, you can factor out a 2, which means then that it's even. So that's going to be k minus 12. It doesn't matter what this is, what k is, and thus what k minus 12 is. It just has to be some arbitrary k. And that's you need to generalize it across to cover every single possible case. So that's from here to here, and now we need to go from here to here. And that's not too difficult either. So we're going to say that c plus 10b plus a as a quantity over 4 is 2. Again, we're going to use m to not confuse it with k. 4 some integer m. You'll impress your teachers if you know how to prove stuff. I mean, sometimes that can be tricky, and that little trick I had on the 7 proof, that second part was that was something that took me a little bit to see and was not obvious. If a number is divisible by both 7 and 8, it's also divisible by 56. 4c plus 10b plus a. So we already have this part, and we just need to get to 100c. That's going to be 8m. Now we need to get from 4 to 100c. So if you write this as 100, whoa, well, where'd that come from? Okay, well, anyway, well, that one sucks, as if to try to prove me wrong. I hate these things. 100c plus 10b plus a. So how did we get from 4c to 100c? We added 96c to both sides. So here we go. So this whole thing is, you can factor out an 8 here. That's the whole point, is that you can factor out an 8 from this. That's going to be 8 and then quantity m plus 12c. MC, like MC Hammer. So anyway, the fact is you can factor out an 8, and also that this is an integer. So because this is an integer times 8, you have divisibility by 8. So that is why these work. So that way I've proven to you beyond a shadow of a doubt, using basic logic and some algebra, that this implies this and this implies this. And that's where I came up with that rule. And now I can prove it. So if you prove stuff to your teachers, that's awesome.